Assalamualaikum. Hello. My name is Muhammad Amir Kamal bin Muhammad Muzaffar. So today we would like to present the topic that I have been given. The name topic is transformer. I will start first and my friends will present after me. So first I will present about introduction of transformer. So basically, transformers are electrical device consisting of two or more coils of wire used to transfer electrical energy by means of a charging magnetic field. One of the main reasons that we use alternating AC voltage and current in our homes and workplace is that AC supplies can be easily generated at the convenient voltage, transform into much higher voltage, and then distribute around the country using a national grid of pylons and cables over very long distance. The reason for transforming the voltage to a much higher level is the higher distribution voltage implies lower currents for the same power and therefore lower loss along the network grid of cables. This higher AC transmission voltage and currents can then be reduced to a much lower, safer and usable voltage level where it can be used to supply electrical equipment in our homes and workplace. And all this is possible thanks to the basic voltage transformer. The voltage transformer can be thought of as an electrical component rather than an electric component. And a transformer basically is very simple static electromagnetic passive electrical device that works on the principle of Faraday's law of induction by converting electrical energy from one value to another. The transformer does this by linking together two or more electrical circuits using a common oscillating magnetic circuit which is produced by the transformer itself. A transformer operates on the principles of electromagnetic induction in the form of mutual induction. Mutual induction is the process by which a coil of wire magnetically induces a voltage into another coil located in close proximity to it. Then we can say that transformers work in magnetic domain, and transformers get their name from the fact that they transform one voltage or current level into another. Transformers are capable of either increasing or decreasing the voltage and current levels of their supply without modifying its frequency or the amount of electrical power being transferred from one winding to another via the magnetic circuit. A single phase voltage transformer basically consists of two electrical coils of wire, one called the primary winding and another called the secondary winding. For this tutorial, we will define the primary side of the transformer as the side that usually takes power and the secondary as the side that usually delivers power. In a single phase voltage transformer, the primary is usually the side with the higher voltage. These two coils are not in electrical contact with each other but are instead wrapped together around a common closed magnetic iron circuit called the core. This soft iron core is not solid but made up of individual laminations connect together to help reduce the core magnetic loss. The primary and secondary windings are electrically insulated from each other but magnetically linked through the common core, allowing electrical power to be transferred from one coil to the other. When an electric current passes through the primary winding, a magnetic field is developed which induces a voltage into the secondary winding, and this basic operating principle of a simple transformer is shown below. In the other words, the first one, single phase voltage transformer. In other words, for a transformer, there is no direct electrical connection between the two coil windings, thereby giving it the name also of an isolation transformer. Generally, the primary winding of a transformer is connected to the input voltage supply and convert or transform the electrical power into a magnetic field. while the job of the secondary winding is to convert the alternating magnetic field into electrical power, producing the required output voltage as shown. The second one is transformer construction, single phase. Vp is the primary voltage, Vs is the secondary voltage, Np is the number of primary windings, Ns is the number of secondary windings, and pi is the flux linkage. Notice that the two coil windings are not electrically connected but only linked magnetically. A single phase transformer can operate to either increase or decrease the voltage applied to the primary winding. When a transformer is used to decrease the voltage on its secondary winding with respect to the primary, it is called a set-up transformer. When it is used to decrease the voltage on the secondary winding with respect to the primary, it is called a step-down transformer. So that's all from me. I will pass the presentation to my friends.
The relationship between the inductance and transformer. Inductance is the property of a device or circuit that causes it to store energy in the form of an electromagnetic field. Induction is the ability of a device or circuit to generate reactance to oppose a changing current, or the ability to generate a current in a nearby circuit. The current flowing in the coil produces a field that expands out of the surround, the conductor. Energy is stored in that field. When the source voltage goes from peak to zero, the energy stored in the electromagnetic field is converted back to electrical energy in the coil conductors. The energy actually opposes the changes in the source voltage. The transformer. Essentially, a simple transformer consists of two coils and excited wire. In most transformers, the wires are wound around an iron containing structure called dead core. One coil or the primary is connected to an input source of alternating current that produces a constantly varying magnetic field around the coil. This magnetic field, in turn, creates an alternating current in the other coil. The secondary coil is connected to a separate electrical circuit to give an output. The ratio of the number of turns in the primary coil to the number of turns in the secondary coil determine the ratio of the voltage in the two coils. For example, if there is 1 turn in the primary and 10 turns in the secondary coil, the voltage in the secondary coil will be 10 times that in the primary. This type of transformer construction is called a step-up transformer.
Hello and a very good morning to everyone. My name is Pavinder and now I'm gonna present about the topic transformer to yours. For my part, I will discuss about the voltage ratio, current ratio and also the efficiency of the transformer. So basically transformer is used to decrease or increase the value of the voltage and the current that flow into it. Firstly, I will start with the voltage ratio in the transformer. As I told before, the transformer can be used to manipulate the amount of voltage value that needed for any demands on the voltage. But the question is how we can change the value of the voltage, and the answer is through the number of the turns in the coil. The number of turns in the coil is directly proportional to the voltage that will produce. In transformer, there will be two coils that will attach with a wire which play the important roles to determine the voltage ratio. To this relationship, we can form an equation which is Vp over Vs, which is the voltage primary over voltage secondary is equal to number of turn in primary and over number of turn in secondary. To determine the type of transformer, either step up or step down, we also can use this voltage ratio as our guidelines. For an example, if the ratio shows that 5:1, it means the transformer is step up transformer. Meanwhile, if the ratio shows that 1:5, it indicates that is step down transformer. I think the explanation of voltage ratio will clarify about it. So let's move on to the current ratio. When the transformer is connected with a load, the secondary current the I2 will produce a demagnetizing flux that proportional to the secondary ampere turns I2 and N2. When the primary current increase, it will providing and increasing to a primary ampere turns I1 and also IN to balance the effect of the secondary ampere turns. The formula that will be used to find the current ratio is I1 over I2 is equal to N2 over N1. Finally, let's move on to the efficiency of the transformer. As a simplified definition, the efficiency of the transformer is a ratio of output to input power. As in every transformer, they will not able to give their efficiency of 100%, but they still can deliver as much as 99.7% of the power. The decreasing in the power will because of the heat loss that produced when the power is transferred via the cable. So that's all from me. Thank you.
Next is the transformer rating. Engineers rate power transformers according to the maximum output voltage and the current they deliver. For a given unit, we will often read or hear about the volt-ampere capacity, which equal product of the nominal output voltage and maximum deliverable current. A transformer with 12 volt output capable of reading up to 10 ampere of current as a voltage ampere capacity of 12 volt times 10 ampere or 120 voltage ampere. The nature of power supply filtering makes it necessary for the power transformer voltage ampere rating to significantly exceed the actual power in watts that the load consumes. A high-quality rush power transformer capable of providing the necessary currents or voltage constitute an integral and critical part of a well-engineered power supply. The transformer is usually the most expensive power supply component to replace if it burns out. So transformer engineers always choose the appropriate transformer rating when designing and building a power supply.
Thank you, Anik. Assalamualaikum. My name is Zaim. I will present to you about example of transformer circuit and calculation. On this slide, we can see a transformer circuit, where on the right side of the circuit is secondary winding because it has a smaller number of coil turns, and on the left side is primary winding because it has a large number of coil turns. Based on this circuit, we can make a calculation to calculate the number of turns of the coil on the primary winding or secondary winding. On this transformer circuits, I want to find the number of turns of the coil on the primary winding. Let's say Vp is equal to 330 volt and S is equal to 15 and Vs is equal to 7.5 volt. By using the formula Ns per Mp equal to Vs per Vp, the number of turns of the coil on the primary winding can be calculated, where the final answer is 160, the number of turns of the coil. I think that's all from me. I will pass to the next presenter, which is Danish. Thank you.
Okay, I'm here again to tell you about the application of the transformer in the real world. For the first application that I choose is the power station and also the national grid. A transformer is a electrical component that will be used to convert the AC voltage of alternating current AC supply, such as the main electrical supply. There will be many sources that will be used to produce the electricity. For an example, in Malaysia, the government is using the charcoal as their main supplies to generate the electricity. The electricity that has been generated will be transferred via the cable across the country. There will be a step-up transformer in the power station to increase the voltage in order to reduce the power loss by the heat producing. but in the other junction there will be a step down transformer to reduce the voltage as they are needed in particular place. For example, for the heavy industry there will be a small step down transformer. Meanwhile, for the household junction there will be a big step down transformer to reduce as much as voltage can. For the next application, we choose the rectifier transformer. This type of transformer is mostly used in industry. The transformer is generally used to convert the alternating current to a direct current in some particular process, such as the electrochemical process, to produce the copper and also the aluminium. So that's all for me. Thank you.
Hello, my name is Mohamed Chazrai. My metric number is AA211385. My part on this presentation is the conclusion. So, in conclusion, by doing this experiment, we all got to know what is a transformer, and based on what we discover, the transformer is a passive electrical component that conducts electrical energy from one electrical circuit to another electrical circuit, or it also can be multiple circuits. It has provided many benefits to the users around the world, such as stepping up voltage up or step it down, because it can work both ways. Next, it also can provide the capability of changing current level easily. We also got to learn on how to deal with the transformer circuits and calculations too. And last but not least, we got to learn how this tool is used worldwide. Surprisingly, without the existence of transformer, there will be no advanced devices such as computers, microwaves, or even power station that transfers electricity for daily usage at our house. Electricity that is brought via the cable by the electric poles near our houses are too strong and big. And the function of the transformer here is to increase the value of the current voltage to allow us to use it and preventing from the house from short circuit accident. That's all from me, thank you.